Today, I will talk about probability models and axioms. So, are you ready to learn about probability model and axioms? Okay, that's good. If you're interested, then I will tell you about probability model and axioms. So let me just run through the uh, table of contents for today's presentation, and we'll go through one by one. The first the first one is we'll go through what is we'll go through these presentations, but let me just briefly give you an overview. Today so just to give you in a background, a probabilistic model is a quantitative description of a situation or a phenomenon or experiment whose outcome is uncertain. To create a model, two steps are required: a sample space. Um, it describes the possible outcome of experiment, that is physical sample space. And secondly, probability laws. It specifies which probability law we are applying so that we can assign probability to the outcome. And we also discuss about axioms and properties that follow from these axioms. Next, we'll talk about examples for models that are related to discrete continuous outcome. And then we'll discuss about more about discrete models and mathematical subtleties of a continuous model. And lastly, but not least, we'll talk about interpretation of probabilities, which means we'll talk about inferencing the probability theory and how it relates in the modern world. So let's talk about sample space. As we said earlier, to create a model, two steps are required: describing all the possible outcome and describing belief about likelihood of the outcome. Describing possible outcome means what are the possible outcome of what we experiment or phenomena. And describing a belief about a likelihood belief about likelihood outcome means now we are trying to describe our beliefs about likelihood of different possible outcomes by specifying a probability law. Next, we'll delve more into detail about the sample space into possible outcomes. So, in the first to learn more about sample space, we have to know the list of the possible outcomes, and then we also need to know the different properties of sample space. That is, they're mutually exclusive, collectively exhaustive, and right granularity. So, let's talk about sample space in more detail. So, list of possible outcomes. It means possible outcomes of an experiment. So, let's say we carry out an experiment, right? Then it can be anything. It can be a flipping a coin, or it can be rolling a die, or any other kind of experiment. So what we do is that we list all the possible outcome of that experiment, or instead of list, it can be a set. It can be a good. It can be we'll create a set of the all possible outcomes, and we'll denote by the capital omega, and then we'll say that this is the sample space, which is all possible outcomes of the experiment. So this list must be mutually exclusive. What does that mean? Mutually exclusive means at the end of the experiment, we can say that this outcome happened and this outcome did not happen. We should not be in a position to say that this outcome also happened, and this outcome also happened. It cannot be that. We should be able to point only one outcome all the possibilities. It has to be mutually exclusive, collectively exhaustive, meaning if you take all the outcomes, then it should exhaust all the possibilities of the outcome of that particular experiment. And right granularity. What is the right granularity of sample space depends upon what kind of question you want to answer. Physically different outcomes should be distinguished in sample space and correspond to distinct points. But when we say physically different outcomes, what do we mean? We mean different in all relevant aspects, but perhaps not in irrelevant aspects. Let us say, to define it more clearly, let us say if we want to answer a question, how many times do we get head if I flip the coin 10 times? For this, a good sample space is a 2 points with head and tails. Now let's say I want to create a second sample space where by flipping a coin, I'm also checking the weather outside the window. Now let's say there are 4 points in this distinct points in sample space. First point represents when it is head and it is raining outside. Second is when it's head and it's not raining outside. Third, when it's tail and it's raining outside. Fourth, it is tail and it's not raining outside. These are 4 distinct possibilities of the sample space. So which one is correct one? If you look at that, we will see. Now let me draw something here. Now we can see that this is sample space, and in this sample space, as I said earlier, there are 4 distinct points: 1, 2, 3, and 4. These are 4 mutually exhaustive. One is rain plus tail, one is not rain plus tail, rain plus head, rain plus not rain plus head. So these are 4 distinct outcomes, and these are mutually exhaustive. So which one is correct one? If you look at the second one, so this is the first one. Let's go back to the first example I gave. It's the head and its tail. So we see that the second one has irrelevant depending upon our. So let's step back a second and review what our question was. Our question was, how many times will I get a head if I flip the coin 10 times? So if that is our question, then we see that the second sample space have irrelevant details that we don't really care about. So the first one is the right granularity, and that's what we are interested in. This is the first one, and this is the second one. So what we can say is that the right level of detail is the one that captures the aspects that are relevant and of interest to you. Hence, we can say that the first one is a right sample space. So what we just talked about is the list of the we define what a sample space is, the possible outcome of sample space, and what are the properties of sample space. Thank you.